Features that were merged yesterday are suddenly gone from main. A developer force-pushed with a stale local copy, overwriting the real history. Let's break down Introduction to Git, how it works, and the exact mistake behind that failure. Git is a distributed version control system that tracks every change to your codebase as an immutable snapshot. Unlike older systems, Git stores snapshots of your entire project at each commit, and almost every operation works locally without a network. A repository is just a folder with a hidden Git directory inside. That Git folder is Git's entire memory, storing every snapshot of your project ever taken. You create one from scratch with Git init or clone an existing one from GitHub. Here's how to set up Git and make your first commit. First, check that Git is installed, then configure your name and email. Create a new directory, initialize a repository, add a file, and commit it. Finally, view your commit history. Git uses a two-step process. First, you stage changes with git add, then you commit them with git commit. Staging lets you choose exactly which changes go into a commit, giving you surgical control over your history. Here's the staging and commit workflow in action. Create a file, check its status, stage it, commit with a descriptive message, and then view your history. The commit message should explain what and why, not just fix stuff. A branch is an independent line of development. You create a branch, make changes, and merge back to main. This lets you experiment without breaking stable code. It's the standard workflow at every professional software company. Here's the full branch lifecycle. Create a branch, switch to it, make changes and commit, switch back to main, merge the branch, then delete it. The merge brings the changes into main, and the branch is no longer needed. Git runs locally, but most projects need a remote home for collaboration. Platforms like GitHub host remote repositories. You push your changes up and pull teammates' changes down. Authentication can be via SSH keys or HTTPS with tokens. To connect your local repo to GitHub, add a remote named Origin, then push your commits. The U flag sets upstream so future pushes are simpler. Use git pull to fetch and merge remote changes. Git stores content as objects: blobs for file content, trees for directory listings, commits for snapshots with metadata, and tags for labels. Each object is addressed by its SHA-1 hash. Change one bit and you get a different address. This is how Git detects corruption. Use git catfile p to inspect raw objects. This shows the tree object referenced by a commit. Understanding the object model demystifies detached head, merge conflicts, and rebase. Git has 3 trees: the working tree your files, the staging area index, and head last commit. Commands like git add, git reset, and git checkout shuffle pointers between these trees. Understanding this triangle makes reset modes clear. If you accidentally stage a file, use git reset head to unstage it without losing your working copy changes. This is safe and keeps your file intact. Git performs a 3-way merge using the 2 branch tips and their common ancestor. If changes touch the same lines, Git marks a conflict with special markers. Your job is to edit the file to keep the correct version, then stage it to mark it resolved. Here's a simulated merge conflict. 2 branches change the same line in app CFG. When you merge, Git cannot auto-resolve and marks the conflict. The file shows both versions with markers. Git communicates over SSH or HTTPS. SSH uses port 22 and key pairs, ideal for scripts. HTTPS uses port 443 and credential helpers, common in CI/CD. For large binary files, use Git LFS to avoid transferring full objects every push. Configure Git to use SSH instead of HTTPS for all GitHub remotes. Increase the push buffer for large repos. Mark binary files in Git attributes to prevent Git from attempting delta compression. Automate Git with shell scripts and hooks. Pre-commit hooks can lint code, prepare commit MSG can enforce ticket numbers. For multi-repo deployments, write a bash loop that clones, tags, and pushes. Share hooks across the team with core hookspath. This script clones multiple microservice repos, tags each with a version, and pushes the tags. Automating multi-repo workflows saves time and prevents human error. Docker containers solve reproducibility. A Docker file is a declarative recipe, and images are built in layers, cached like Git objects. Pair a Git tag with a Docker image tag for full traceability. Never tag containers with latest, it defeats reproducibility. This Docker file uses multi-stage builds. Layers are cached. If package, JSON doesn't change, npm install is reused. Only changed layers rebuild, similar to Git's SHA one-tree hashing. GitOps extends Git's declarative model to infrastructure. Store Kubernetes manifests in Git, and a tool like Argo CD automatically applies changes to the cluster. Rollback becomes Git revert, and auditing becomes Git log. This Kubernetes deployment includes a Git commit label and an image tag matching the Git SHA. This enables full traceability. You know exactly which code version is running in each pod. This is the same issue we highlighted at the start. Here's exactly why that happened. The developer ran Git Rebase main on their feature branch, then later rebased main locally against an outdated remote. They skipped Git fetch. When they force-bushed with force-with-lease, the lease checked their local ref against what they last fetched, not the current remote state. Since they hadn't fetched, the lease passed, and the force-bush overwrote main with stale history, deleting merged features. The developer rebased main locally without fetching, then force-bushed with stale refs, overwriting main and deleting merged features. To fix, first do not pull, that would propagate the damage. Find the last good commit SHA from a teammate's reflog or CI logs. Then force-bush that SHA to restore main. Git push force origin goodshaw, main. All teammates must then run git fetch and in git reset hard origin main to sync. A developer rebased main locally against an outdated remote, then force-bushed. The lease check passed because their local ref matched what they last fetched, but they hadn't fetched since teammates pushed. The force-bush overwrote main with stale history, deleting merged features. Force-bushing to a shared branch like main is dangerous. Even force-with-lease can fail if your local ref is stale. Always use branch protection rules to disallow force-bushes to main and only force-bush to personal feature branches. Blind git pull can create unexpected merge commits if your local branch has diverged. Prefer git fetch first, inspect with git log head. Origin main, then decide to merge or rebase. Set pull rebase true for cleaner history. Committing sensitive data like API keys is a security risk. Even if you delete the file later, it remains in history. Rotate the secret immediately, use git filter repo to remove it from all history, and add the file to git ignore. The article mentions rebase and merge, but doesn't emphasize that rebase rewrites history, which can cause issues for collaborators. In production, never rebase commits that have been pushed to a shared branch. Use merge for shared branches to preserve history and avoid force-bush disasters. The article mentions reflog as a safety net, but doesn't show how to use it to recover a lost commit. Here's a concrete example. After an accidental git reset hard, use git reflog to find the lost commit SHA and git cherrypick to restore it. The article warns against force-bushing, but doesn't explain force-with-lease. This option checks that your local remote tracking branch matches the remote before force-bushing, preventing accidental overwrites of others' work. Always use force-with-lease instead of force on shared branches. When things go wrong, use git reflog to find lost commits, git bisect to find the commit that introduced a bug, git blame to see who changed a specific line, and git stash to temporarily save uncommitted work. Let's run through some common interview questions. What is a fast-forward merge? Git moves main pointer to branch tip, no merge commit. What is the difference between git fetch and git pull? Fetch downloads changes without merging, pull fetches and merges. How do you recover a lost commit? Use git reflog to find the SHA, then git cherrypick or git branch. And a few frequently asked questions. What is the difference between Git and GitHub? Git is the version control engine. GitHub is a hosting platform. Is Git free? Yes, Git is open source and free. GitHub offers free tiers. How does Git handle simultaneous edits? It uses three-way merge. Conflicts arise only when same lines are edited. To recap, Git is a distributed version control system that tracks changes as immutable snapshots. Use the two-step commit process for precision. Branches let you experiment safely. The reflog is your safety net. Never force push to shared branches. And GitOps brings version control to infrastructure. Ready to go deeper? Up next, Git branching and merging, then Git rebase versus merge, then Git stash and cherry pick. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.